4-1, quadratic functions and transformations. So in this section, we're going to identify and graph quadratic functions. And the essential understanding is that the graph of any quadratic function is a transformation of the graph of the parent quadratic function, which is y is equal to x squared. Okay. So to start, let's look at this little computer game, steeplechase. So in this game, you press the jump button and the horse makes the jump shown over here on the right, okay, right there. And the highest part of the jump must be directly above the fence or you lose time. Where should this horse be when you press the jump button? All right, so if I look at this, the highest point on the graph over here is at x is equal to 2. That means that if I want the horse to get as high as possible, I have to press jump 2 spaces before the gate right here. And the gate is at 4.5. So that means I should press the jump as soon as the horse gets to 2.5. And then this horse will jump up and then come back down and land 2 past the gate. Okay? And we can tell that if we were to continue this graph, kind of like this, it would form the shape of a parabola. Okay. So in the solve it, you use the parabolic shapes of the horse jumps, and we see that a parabola is the graph of a quadratic function, which you can write in the form f of x is equal to ax squared plus bx plus c, where a is not equal to 0. And the reason that a can't be equal to 0 is because if it was, this whole thing would be 0, and then we wouldn't have a quadratic formula anymore. We would have a line, bx plus c. Okay? So, and a parabola is just going to be the curve that we just saw on the last page. Right? This formula right here is standard form. Today, in this section, we're going to talk about vertex form. So my vertex form of a quadratic function is f of x is equal to a times x minus h squared plus k, where a is not equal to 0. Okay. We'll get to that. The axis of symmetry is the line that divides the parabola into 2 mirror images. And the equation of the axis of symmetry is going to be x is equal to h. The vertex of the parabola is h comma k, just like the vertex of an absolute value equation. And the vertex of a parabola is the intersection of the parabola and its axis of symmetry. And if we remember back, if we look at vertex form right here, and we remember back to my function for an absolute value equation, looks something like this. X minus h plus k. And in this case, h and k was the vertex of my absolute value function. And now hk is going to be the vertex of my parabola. So these two functions kind of work the same way. Okay. So here's a picture of the parent quadratic function. Notice that the vertex is at 0, 0. The axis of symmetry is at 0. And it looks like a nice smooth curve. All right. And if I wanted to figure out the points on this curve, I can plug numbers into my parent function. Okay. So the first thing we're going to try to do is let's try to graph a quadratic. Okay. So we have our graph right there, 1/2 x squared. Well, I should be able to tell, first step, is the vertex. So the vertex of this thing, okay, is going to be h comma k, but this doesn't have any h and it doesn't have any k. So my vertex is going to be 0, 0. So let's first put a dot right there, 0, 0. Okay. Next, let's plot some points to the right and to the left of the vertex. Okay, well, in order to do that, we'll make a little graph. If I plug in 2 for x, 2 squared would be 4 times 1/2 would be 2. Okay, plot that point. Let's put one more. 4. I'm picking even numbers because I'm going to eventually multiply them by 1/2, and I don't want to get a fraction. Okay? So plug in 4. 4 squared is 16, so I would get 8. And so I would go 8 right there. Okay? Now, what I can do, because I know that at the vertex, I have my axis of symmetry, so I know that the graph is symmetrical on the right and the left. I can reflect these points on the right over to the left, and they are the same distance away from the axis of symmetry, only the other way. If I don't want to do that, I could, of course, plot some negative numbers, plot the same points, but I know I'm going to get the same answers. If I plot -2, I'm going to get 2 again, because when I square -2, it turns positive. And now that I have my points, now I can draw a nice, smooth curve. And there's the graph of my function. Okay? So I can do the same thing with this graph right here, only now I'm going to get a negative number. H and K is still 0, so I can plot that point. And now let's plug in X and Y. Let's plug 3 in. 3 squared is 9 times -1/3 is going to be -3. Okay? So when I plug in when I plot that point, I have 3, -3. And I can also reflect it around my axis of symmetry, which is right down the middle again. Yeah, the formula for the axis of symmetry is x going to be equal to 0. Okay? And I can plot some more points, but I kind of get the idea, and this is going to go kind of like that. Okay? Which leads us down here to what we can say about the graph of the function ax squared if a is a negative number. So as we look here was a for my second function, and here was a for my first function. I can realize that if a is a negative number, the graph is going to open down, okay? Which is something that we've seen in the past, especially with absolute value functions. Okay, and that's what this says here. The graphs of y is equal to ax squared and y is equal to -ax squared are reflections across the x-axis. Increasing the absolute value of a stretches the graph vertically and narrows it horizontally. As a gets bigger, that is a vertical stretch. And decreasing a compresses the graph vertically and widens it horizontally. And we can see that on this picture right here. Okay? So if we look at the first picture, where you see that we have in blue, we have x squared. In red, we have -x squared, which is a reflection across the x-axis. In the middle graph, we have 2x squared, and we can see that it is thinner. And in the right-hand side graph, we have 1/2 x squared, so we can see that that graph is a little flatter than x squared. Now, if a is bigger than 0, the parabola opens upward. We know that already. The y-coordinate of the vertex is going to be a minimum value of the function. Because if this graph opens up, like it does in this picture, we can see that right down there at the vertex, the function cannot get any lower than it is. Okay? And that happens when a is positive, which means that that function has a minimum value at some point. We can see what the point is right there, it's 0. And we can figure out what those points are once we learn how to figure out where the vertex is. But for now, we know that it has a minimum function. Okay? The opposite is true as well. That if a is less than 0, the parabola opens downward, and the y-coordinate of the vertex is the maximum value. And I can see that in this picture on the right, where the parabola opens down, and my vertex is the highest that that function can ever go. Okay. So let's talk about a translation. Okay. So how is each graph a translation of f of x is equal to x squared? Okay. So we should remember back from translations that h moves the function left and right, and that k moves the function up and down. Okay? So in this case, a minus 5 is going to move the function down 5. Okay? And I'm not going to graph at the moment. All I want to talk about is where the function moves. So in this case, the function moves right 4 because the negative 4 is inside of the function. Okay? For A, this moves up 3, and for B, that is a left 1. Okay? And if you need to review transformations, they're back in chapter 2. Okay? So now, vertex form, what we saw at the beginning of the section. A times x minus h squared plus k gives me information about the graph without actually having to draw it. We saw already that if a is greater than 0, we have a minimum, and if a is less than 0, k is the maximum. Okay? So the y coordinate of the vertex is going to be my minimum or maximum value. That brings us to this, that if we look at vertex form, okay, we can figure out a whole bunch of information about the function just by looking at my equation. Okay? So what are the vertex axis of symmetry, the maximum or minimum, and the domain and range? So first, let's do the vertex. Okay? The vertex is the coordinate h comma k, which would be 4, negative 2. The axis of symmetry. The axis of symmetry is going to be the x coordinate of the vertex. So that's going to be x is equal to 4. Okay? I don't want to equal sign. Okay? The axis of symmetry is x is equal to 4. Okay? The minimum or maximum value depends on whether or not a is greater than 0 or not. So in this case, a is equal to 3. So a is greater than 0, which means this function has a minimum value. So it has a minimum value because it opens up. So the minimum value is equal to, the minimum value is y is equal to the y coordinate of the vertex, negative 2. Okay? Domain for most parabolas, every time we get a normal parabola that's not a word problem, and so my domain isn't limited, the domain is going to be all real numbers. Okay? My range, however, is always going to be limited. Okay? So my range is going to be limited because the minimum value of this function is y is equal to negative 2. That's the smallest this function can ever get. So that means y has to be greater than or equal to negative 2. Okay? Okay? So the same thing here, the vertex is going to be negative 1, 4. The axis of symmetry is going to be x is equal to negative 1. The a is negative, so a is less than 0. So that means there's going to be a maximum value. So the maximum is going to be y is equal to the y coordinate of the vertex. So we're going to use the vertex for a couple different things. And in this case, all we have to do is look at a to decide whether or not we have a maximum or a minimum value. Okay? So the max is y is equal to 4. My domain is all real numbers. And my range is y is less than or equal to 4. Okay. So we can use vertex form of the function to transform the graph of the parent function f of x is equal to x squared. Okay? We can stretch or compress the graph by the factor of whatever a has to be, the absolute value. Okay? If it's less than 0, then it reflects across the x-axis, and we shift the graph h units horizontally and k units vertically. A positive h shifts the graph to the left. A negative h shifts the graph to the right. A positive k shifts the graph up. A negative k shifts the graph down. Okay? And here are some pictures to go with it. At the horizontal translation, we can see that we shift the graph h units, and it is a minus h. A plus k shifts the graph up, and here's both of them together. Okay? And my vertex changes as I move up, down, or left, right. Okay? Okay. So with this, I can figure out the graph just based on vertex form. So the first step is identify my vertex. So my vertex is going to be 1, 3. Okay. A is going to be negative 2. Okay. So that tells me that my graph is thinner and flipped over. Okay. So if I were to graph this, okay, I would plot my vertex first. And without a nice graph, it's not going to be pretty. So 1, 3, that's my vertex. I know it's going to open down, and I know it's going to be stretched out. So instead of going 1 over, I'm going to go down 1 over 2. And I'm going to reflect that point like that. And we're going to get a graph something like that. And I know my axis of symmetry is at 1, and my vertex is at 1, 3. Okay. So let's take all that information and let's look at this picture of a dolphin and let's figure out the vertex form of this parabola. I see from the picture that he's going down, okay, but first I need to figure out the vertex. So the vertex is going to be 3, 7. That's the highest point that function ever goes. So my vertex is 3, 7. Okay. Now I need another point. Well, first of all, let's look at vertex form. Vertex form is y is equal to a times x minus h squared plus k. Okay. Well, I know h and k right now. If I had another point on the graph, then I would know x and y. Then I would know y, x, h, and k. And the only thing that would be left to solve for would be a. Okay. Well, I can figure that out. Get rid of those. I can figure that out. There's another point on this graph that I can use. And how about 9 and how about 9 and 4? Okay. So I have another point. 0.94 is on my graph. Okay. So now, plug in my numbers. Y is equal to 4 because that's a point. A, I don't know. X was 9. The vertex was 3 plus 7. Okay. I can now solve this equation for A and then rewrite this in vertex form. So let's do it. So 9 minus 3 gives me 4 is equal to A times, well, actually, 9 times 3 is, 9 minus 3 is 6 squared, so that's 36A plus 7. Subtract 7 from both sides, and we get A. Negative 3 is equal to 36A. Divide by 36. Whoops. So A is going to be equal to negative 3 over 36 reduces to negative 1/12. Okay. Using A and my vertex, I can now plug the right numbers into standard form. So y is going to equal negative 1/12 x minus 3 squared plus 7. Okay. And that is my vertex form of my parabola.